Everyone, in today class we are going to just have the continuation of last class topic, that is ESU unit. So in this class we are just going to have a discussion on what are the important component or important building block of ESU unit, that is the power oscillator, because we already know the ESU unit is meant for generating high frequency current, right? So the power oscillator is the one component that is act as a important or heart of the component of ESU, which is meant for generating high frequency current. So there is two type of power oscillator which is being used in ESU machine. That is, one is a spark gap oscillator, second one is solid state oscillator. The spark gap oscillator will generate the frequency which is damped frequency. It is especially suitable for coagulating all kinds of tissues, whereas the solid state oscillators, it generates undamped high frequency, which is mainly used for where you want to make precise or clean cut. So these are the two different oscillators you can see. One is a spark gap oscillator, second one is solid state oscillator. So again I'm repeating, the spark gap oscillator will produce a damped high frequency, and solid state oscillator is producing undamped high frequency. The one is for cutting, and another one is for coagulation purpose. So now let me ask you one question: what is difference between damped high frequency and undamped high frequency? So first we should know the difference of these two, right? So then only we can know where and how where and how we can use this particular frequency for the applications of cutting and coagulation. So damped high frequencies, like this frequency will maintain their it will lose the height and amplitude of the frequency at one point. It will not maintain throughout the duration, right? So for example, if you see, if you bouncing the ball, so initially it will goes at very height, and later on slowly it will, the amplitude or frequency will slowly deteriorate. At one point it will get settled down. That is the example of damped high frequency. So similarly, this particular frequency initially will have very height and amplitude, and slowly the amplitude will get deteriorated at one point. So that is called a spark gap oscillator. So it is being used for coagulation purpose. The solid state oscillators, where you can use undamped high frequency. We are not dumping any frequency, so that there won't be any loss of amplitude. So it will maintain the same constant amplitude and frequency of that signal. So that is what undamped high frequency. So this, because of this reason, we are using this particular undamped high frequency signal or the current for making precise cut. So in order to make precise cut, we need a very constant amplitude and frequency current, so that the intensity of, in the full power of intensity will reach to the tissue, so the process of cutting will happen. So this is the difference between damped high frequency and undamped frequency, and why these difference is there, and why this damped frequency is used for coagulation, and why the undamped frequency is used for cutting, we have discussed. So next we will be seeing what are the different electrodes, okay? And also before that, we have to know what is the cutting current intensity, what is the coagulation current intensity we have to set in ESC unit. For cutting, we have to set the watts of 400, for internal resistance of 500 ohm, for the load called for load internal resistance of the load 500 ohm at 2000 voltage. Similarly, for coagulation, it delivers 150 watts. So if you see, the cutting have very high intensity compared to the coagulation. This is the reason you have to set different content intensity level for different process, whether it cutting or coagulations. So the next we will be discussing like what are the different electrodes we can see in ESU unit. So there are plenty of electrodes. Based on the application, we can use the different sort of electrodes. If you see the different types, it is based on their tip, how it's been designed. If it is a needle or pinpoint, then it is called a needle electrodes. If it is a bended at some angle, then it is called angulated electrodes, or it is being connected with a wire loop, then it is called wire loop electrodes. electrode, and similarly you have angulated lancet wire loop electrode and lancet electrode. So these are different sort of electrodes you can see, and you can connect it to the pencil active electrode where you want to and where you want to make a precise cut, or if you want to make a coagulate the cells. So based on the applications we can use different types of specific types of electrodes. So these are the thing we can use, and apart from this there are other two electrodes is there. One is active electrodes, another one is passive electrode. So the active electrode, as you know already, that this is the one kind of electrodes will going to deliver the current to the patient. All right, so the important thing you have to consider when you are designing or choosing the active electrode is that is the active electrode resistance. The reason is that whatever the power is being delivered to the tissue, the given voltage is depends upon what is the active electrode to skin resistance, that is the RE. Okay, so these are the different resistance path we have to think, or we have to consider while we are setting the watts intensity in the ESU unit, because the power which is to be delivered to the in tissue, it should be good enough in order to make the process called cutting or coagulation. If you are not considering this intensity internal resistance, then what the value what you are setting will when it reach to the tissue through this way, there will be some drop of power. So at the end you will not have a good enough of intensity or the power, so that the cutting or coagulation process will not happen. So that is the reason whenever you are making or any sort of electrodes, you have to think about what is the active electrode resistance, what is the interaction or resistance which you can see in active interaction of electrode to skin, and then body resistance and return electrode resistance. You have to think about all these four resistance when you are designing the any electrodes, that is the active electrodes or the passive electrodes. And next one is like passive electrodes. So similarly a similar kind of things you have to consider when you are designing passive electrodes, or you can also say neutral or return electrode, because this the electrode is going to remove all current from the patient safety, right? So whereas the active electrode is meant for delivering the current to the patient, so that we are making giving, we are giving more attention or more focused on designing of active electrode, because the internal resistance is its main important parameter, where there will be some power drop will be there, right? So similarly, if you see the passive electrode, there are certain things you have to be considered when you are designing, because this is going to remove the current whatever being distributed in the body from the patient, so that we are going to give a good patient safety. That is, we can enhance the patient safety in this ESU unit. So how we can do consideration for this design for designing of this passive electrode, in the sense the first point is like you have to make a sufficiently large contact area, and second one is like you have to give very good electrical conductivity between body and electrodes. These are the 2 points we have to give more importance when we are designing the passive electrodes. So these are the overall informations about what are the different electrodes, that is active electrodes and passive electrodes. Apart from them, we have a different size of electrodes and shape of the electrodes. Based on the application we can go with. And we also discussed the important oscillators, power oscillators, which is used in a ESC unit. One is spark oscillator, another one is solid state oscillators. Thank you.